Hi everyone, in this video I'll be going through the 2024 Sec 3 G3 A Math end of year examination paper, so please make sure you have finished the paper before watching this video. Let's get started. Okay, let's look at question number 1. Okay, given this equation over here, let's turn this expression into the form of ax plus b squared plus c. So this is a complete the square question, and always remember, in order to complete the square, the coefficient of x squared must be 1. So my first step to this question should be to factorize out the coefficient of x squared, which is 4. So by factorizing out of 4, I'll get x squared minus 4x plus 11 over 2. Okay, then from there I want to complete the square, simply add plus b over 2 square. My b, in this case, the coefficient of x is negative 4. So this is equal to 4 x squared minus 4x plus negative 4 over 2 square minus away negative 4 over 2 square plus 11 over 2. Okay, so from here this can simplify to become, the first three terms will become x minus 2 the whole thing square. Okay, then minus away minus 4 plus 11 over 2. Okay, so once we simplify everything, I will get 4 times x minus 2 the whole thing square plus 6. Okay, so a common mistake is this 4 here. Remember, this 4 will have to multiply to this entire value over here. So make sure you check and don't make careless mistakes in this case. Okay, so this is the answer for question 1a. Let's move on to question 1b. Hence explain why this value of y is always positive. So I know that y is given by this expression over here. Well, explain why this is always positive. So we know that anything x minus 2 the whole thing square is always greater than or equals to 0 for all values of x. So in this case, 4 times x minus 2 the whole thing square is greater than or equals to 0. If I plus 6, 4x minus 2 square plus 6 is always greater than or equals to 6. Therefore, this means that y is always greater than or equals to 6, which is more than 0. Therefore, this is explaining why y is always positive. Okay, so over here, therefore, y is always positive. Okay, and this is the explanation to part B. Alright, let's now look at part C. Okay, given that this is a perfect square, find the value of p. So I know that y can be written in the form y is equal to, I know that this expression here can be turned into 4 times x minus 2 square plus 6. Then I have a plus p over here. Okay, what does it mean for something to be a perfect square? So perfect square means anything, any number here that is a square. Okay, this entire expression is called a perfect square. So for example, e.g., okay, 3 square, 4 square, these are all perfect squares, which is 9, 16, 25. So over here, if I look at this expression, how do I make this a perfect square? For this to be a perfect square, this means that I want this whole number here to be able to be written in the form of something square. Okay, so if I were to analyze this expression over here, I notice that 4 can be written as 2 square, okay, times x minus 2 square, okay, plus 6 plus p. So over here, if I continue to simplify, I notice that this can turn into 2 times x minus 2 the whole thing square plus 6 plus p. So therefore, in order for this to be a perfect square, I want to get rid of this thing over here, okay, such that this whole thing here can be something square. So therefore, in order to get rid of 6 plus p, therefore, p must be equals to negative 6, so that 6 plus p can be equals to 0. Okay, so therefore, this is the answer for part C. P must be equals to negative 6. Take note, I think some people make this mistake. Note, if I have 3 square, let's say 3 square plus, let's say 5 square, because some of you may think that I must make this number something square, like p equals to 3, so that this is 3 square. This is wrong, because the sum of two squares is not a perfect square. It's not a perfect square. This is the reason why in this case over here p cannot be 3. Okay, in this case, for something to be a perfect square, the entire expression should have the powers 2. There should be no other numbers that's added to this expression. Okay, this is for 1c. Let's now move on to question 2. Question 2, express this in the form of a plus b root 7. Very simply, all we need to do is to rationalize this expression. So by rationalization, I multiply 4 plus root 7. Okay, 4 plus root 7. I will get 36 plus 9 root 7 divided by 4 square minus 7. Okay, so this will be 36 plus 9 root 7 divided by 16 minus 7, which is 9. Simplify your answer, you should get 4 plus root 7. This is for part A. Okay, so once I've rationalized this correctly, now since the next part is a hence question, hence if this is equal to this, find the value of p and of q. So this means that I use the part A answer. This means 4 plus root 7 equals to square root of p plus q root 7. Find the value of p and q. So very simply, what we can do to find p and q, let's get rid of the square root here first by squaring both sides. So this means that 4 plus root 7, the whole thing square, is equal to p plus q root 7. Okay, therefore expand and simplify. This will be 16 plus 8 root 7 plus 7 equals to p plus q root 7. So therefore, this means that 23 plus 8 root 7 is equal to p plus q root 7. So therefore, by comparison, we can clearly see that p is equal to 23 and q is equal to 8. Okay, and this is the answer for part B. Alright, let's now move on to question number 3. Okay, find the range of values for which this thing here is greater than or equal to 16. Take note, common mistake. Many people will do this. 2x plus 1 is more than or equals to plus minus square root of 16. Okay, this is wrong. Why is this wrong? This does not make sense. You cannot square an inequality because when you square an inequality, you're saying that 2x plus 1 is bigger than negative root 16 and bigger than positive 16. This is a contradiction, and it is not possible for us to take square root of inequality. So what we should do is that, remember, to solve inequalities, we must always make the right hand side 0. So for we start from here, square root 2x plus 1, the whole thing square, more than or equals to 16. We expand out the left side first. Okay, so this can, or you can either expand out or you can simplify. So by expansion, this will give me 4x squared plus 4x plus 1 more than or equals to 16. Therefore, 4x squared plus 4x minus 15 is greater than or equals to 0. So now I have a quadratic expression on the left side. I can factorize now. By factorization, I should get 2x plus 5 times 2x minus 3 greater than or equals to 0. Then from here, how do we solve a quadratic inequality? Next step is to sketch the curve. So I identify over here, based on my coefficient of x squared, for positive, this is a smiley face curve. Okay, the two x-intercepts is simply let this be equal to 0. I can find the two x-intercepts, which will be negative 5 over 2 and 3 over 2. Okay, then from here, more than equals to 0, I want the part of the graph that is above the x-axis. So this means I want this part of the graph and this part of the graph, which is greater than 0. Okay, so therefore final answer, therefore x is less than or equals to negative 5 over 2, or x is greater than or equals to 3 over 2. And this is the answer to question 3a. Alright, let's now look at question 3b. Find the range of values for which of p for this inequality over here. Okay, so to solve this inequality, I want this expression to be less than this expression. You can notice this is a line, this is a curve. So when I see a quadratic inequality, the steps are the same. Step 1, make right hand side equals to 0. So what I'll do is that I have negative 3 minus px less than x squared plus 3x plus 2p. Okay, so over here, I usually like to leave my x squared coefficient to be positive. So let's say I subtract the terms on both sides. Okay, I'll get 0 is less than x squared plus 3x plus px plus 2p plus 3. Okay, so we can rewrite this. Usually I like to see on the left hand side instead. So x squared, these two terms can actually combine together. 3x plus px, this can be written as plus 3 plus p the whole thing times x, then plus 2p plus 3. This expression is greater than 0. Okay, I'm doing this so that I can easily see that my right hand side is equal to 0. Okay, then from here, okay, for this quadratic expression here, this is a smiley face graph. For this to be greater than 0, this means that, what does this mean? This means that for the equation x squared plus 3 plus px plus 2p plus 3 is equal to 0, the discriminant of this equation here, okay, is less than 0. Why is it less than 0? It is because this inequality tells me that this smiley face curve here lies above the x-axis. For a smiley face to lie above the x-axis, there is no intersection between the curve and the x-axis over here. So no intersection means no real roots. Discriminant is less than 0. Okay, so if discriminant is less than 0, therefore we know that the b squared minus 4ac is less than 0. Now I can sub in my ABC. B squared, b is 3 plus p the whole thing square minus 4 times 1 times 2p plus 3. This entire thing here is less than 0. Okay, so from here I continue to simplify. I will get p squared plus 6p plus 9, then minus 8p minus 12 less than 0. Okay, simplify everything, I should get p squared minus 2p minus 3 less than 0. Factorize this. P minus 3 times p plus 1 less than 0. So, sketch your curve. Smiley face graph, since the coefficient of p squared is positive. Intersections are negative 1 and 3. Since this part here is less than 0, this means I want the part of the graph that is below the x-axis, which is this part over here. Okay, so therefore, answer, p is between, strictly bigger than negative 1 and less than 3. And this is your answer to question 3b. Okay, alright, let's now move on to question number 4. Question number 4. The expression has a remainder of negative 1 when it's divided by x and a remainder of negative 3 when it's divided by x plus 1. Find the value of a and b. Okay, so over here, very simply, whenever I see such questions, right, I always like to define my expression first. I'll let fx be equals to this expression, x times x squared minus 1 times 3 minus bx plus ax plus b. Okay, so step 1, we first read the question first. We use the information provided. Remainder of negative 1 when it's divided by x. This means that when I sub x equals to 0, by remainder theorem, I get a value of negative 1. Okay, so therefore, this means that over here, f0 means I sub in x equals to 0, because when I divide by x, I sub in x equals to 0. This will be 0 times 0 square minus 1 times 3 minus 0 plus a times 0 plus b. And if you notice, right, 0 times this entire expression, this will become 0. 0 times a is 0. I'm just left with b. Therefore, this means that b is equal to negative 1. Okay? Next part. For the next information told to us, remainder is negative 3 when it's divided by x plus 1. So therefore, when I sub f, When I sub x goes to negative 1, the value by remainder theorem, I get negative 3. So if I sub everything in, f negative 1 is equal to negative 1 times negative 1 square is 1 minus 1 times over here 3 times negative 1 times this is plus b, then plus a times negative 1. Then I know that I found that b is negative 1 minus 1. Okay, so from here, notice this 1 minus 1 gives me 0. So I'm left with over here, this is equal to, this whole thing here is just 0. I'm left with negative a minus 1. So therefore, negative a minus 1 is equal to negative 3. This means that a is equal to negative 1 plus 3, which is equal to 2. Okay, and with that, we have found the value. Therefore, a is equal to 2, b is equal to negative 1. This is for question 4a. Okay, let's now move on to question 4b. Okay, so over here, I now sub in the values of a and b first. Hence, find the remainder. So hence means I must use my answer in part A. I know that the expression now is fx is equal to, let me write out, x times x squared minus 1 times 3, b is negative 1, so 3 plus x plus 2x minus 1. So find the remainder when the expression is divided by 3x plus x squared. Notice this actually means x times 3 plus x. And I notice over here from my expression, right, x and 3 plus x is found in my expression here. So that means when I divide by this x, 3x plus x squared, okay, let me rewrite. So fx can be rewritten as x squared minus 1 times 3x plus x squared plus 2x minus 1. Oops, that's okay. So over here, this is my 3x plus x squared. Okay, and actually if you notice, this is actually in the form of, if I treat this as my divisor here, 3x plus x squared, I will have a quotient and a remainder. Therefore, this means that, remainder is simply equals to 2x minus 1. Okay, and this is the answer for part B. Because whenever I divide any polynomial by a divisor, I always get a quotient and remainder. And in this case over here, this expression can be nicely written in the form of, if this is the divisor, the quotient will be this and the remainder will be this. Okay, and this is for question 4 part B. Alright, okay, let's now look at question 5. Express this fraction in its partial fractions. Step 1, we check, is it a proper or improper fraction? Power in the numerator is same as power in the denominator. Therefore, this is an improper fraction. So the moment that this is an improper fraction, what should we do? Step 1 is to use long division. Okay, so to use long division, we have to take over here, the divisor is x squared minus 4. Okay, this thing divided by x squared plus 4. Okay, so over here, if I divide by long division, I'll get 1. So I'll get x squared minus 4. Okay, then minus away. Remainder will be equals to 8. Okay, so therefore, this means that x squared plus 4 divided by x squared minus 4 is equal to the quotient 1 plus remainder 8 over divisor x squared minus 4. Okay, then from here, now I want to turn this into its partial fractions. So over here, I'll let 8 over x squared minus 4 be equals to, we note that x squared minus 4 can be factorized to become, the denominator can be factorized further to become x plus 2 times x minus 2 first. Okay, so remember, always check, denominator must check that it's fully factorized first. Once I check that it's fully factorized, cannot be factorized any further, then I can assign its partial fraction. Since my denominator has two linear factor, this can turn into a over x plus 2 plus b over x minus 2. Okay, where a and b are constants to be found. Okay, and once I reach this state, my next step is to get rid of the fraction by multiplying x plus 2 times x minus 2 to the entire equation. 8 is equal to a times x minus 2 plus b times x plus 2. Now, in order to find a and b, I'll sub in different values of x. Over here, to find a, let's say, or to find b, I can sub in x equals to 2. When I do that, I can get rid of a over here, because 2 minus 2 will become 0. So therefore, 8 will be equals to b times 2 plus 2. Okay, so therefore, 4b is equal to 8, b is equal to half. Likewise, I can also do the same to find a. I can sub x equals to negative 2. Okay, I would get 8 equals to a times negative 4. So therefore, a is equal to 8 divided by, sorry, this part should be 2. Why did I write half? Okay, 8 divided by negative 4. For the other side here, 8 divided by negative 4, this should be negative 2. Okay, so therefore, once I have obtained this form here, I can now simplify this entire thing into its fully decomposed form, which will be x squared plus 4 over x squared minus 4 can be rewritten to become 1 plus, then over here, this thing here will turn into this. Since I found a and b, this will be 1 plus negative 2 over x plus 2 plus 2 over x minus 2. But take note, this is not fully simplified. There should be no negative sign and a plus sign like this, because you can bring the negative sign down. Fully simplify this to become 1 minus 2 over x plus 2 plus 2 over x minus 2. Okay, final answer statement is important. You will lose marks without this final answer statement. Okay, and this is your answer to question number 5. Alright, let's now look at question number 6. Okay, question number 6, given this equation here, show that 18 power x is equals to this. Okay, so very simply, we start from the original equation given 3 power 2x minus 1 plus 9 power x plus 1 equals to 2 power 1 minus x. So very simply over here, right, if in order to get 18 power x, I must separate out all the x in the power. So let's use our laws of indices. I can separate out this to become 3 power 2x times 3 power negative 1 plus 9 power x times 9 power 1 equals to 2 power 1 times 2 power negative x. Then I continue to simplify. Power negative 1 can turn into 1 over 3. So this is 3. And also here, this 3 power 2x can actually be written to become 3 square the whole thing power x. Okay, times 1 over 3 plus 9 power x times 9 equals to 2 times negative power, I can turn into 1 over 2x. Okay, simplify further, I will get, this will give me 1 over 3. 3 square is 9. So this is 1 over 3 times 9x plus, this is 9 times 9 power x equals to 2 over 2 power x. Okay, then from here, I can simplify 1/3 of 9x plus 9 times of 9x. This will combine to become 28 over 3 power 9x equals to 2 over 2 power x. Okay, then from here, I can continue to simplify further. Okay, so over here, maybe if I were to rewrite this as an fraction on both sides, you can see that this is 28 times 9 power x over 3 equals to 2 power over 2 power x. By cross multiplying to get rid of the fraction, I will get 28 times 9 power x times 2 power x equals to 6. So this means that 18 power x, I can combine these two together. Let me write this 9x times 2 power x is 18 power x is simply equals to 6 over 28, which can be simplified to become 3 over 14. Okay, and this is the answer to part A. Alright. Then for part B, hence find the value of x. So I know that given this expression here, therefore for part B, very simply, to find x, remember we can take ln or log to bring down unknown powers. So if I take log, let's say I take log or ln on both sides, log 18 power x is equal to log 3 over 14. Okay, then from here, we can use power law to bring down the unknown power. X log 18 is equal to log 3 over 14. So therefore, x is equal to log 3 over 14 divided by log 18, and you can press in your calculator. Your final answer should be negative 0.533 rounded off to 3 SF. Okay, and this is your answer to question 6 part B. Okay, let's now look at question number 7. Question 7, solve the following equation. I have log x equals to 4 log base x 10. So how do I solve this question over here? Very simply, all you need to do in this case over here is make them the same base. In order to do that, what will we do over here? Remember in your calculator, you can only calculate log base 10. So logically, the step you should do is to turn this base x here into base 10. So what can we do over here? Okay, I want to change to base 10. Log x equals to 4. Change to base 10. It will be log base 10 over log base 10x. Okay, this can be simplified. Log x is equal to 4 times 1 over log x. Remember, log base 10 can be written as LG. Okay, so this is simply log x equals to 4 over log x. Get rid of a fraction by cross multiplying. I'll get log x the whole thing square equals to 4. Take note, common mistake. Some people will write log x square. This is not the same as this. Okay, remember, this thing is not the same as this. Why? Log x the whole thing square means, this means log x times log x. This thing here means log x or 2 times of log x. Two different meanings. Don't necessarily have the same value for different values of x. Okay, so this thing here, if you put this like this thing here is wrong. Okay, please do not make this mistake. Alright, so from here, from this step over here, log x the whole thing square is equal to 4. To find log x, we take square root. Log x will be equals to plus minus 2. Okay, so therefore this means that log x is equal to 2, or log x is equal to negative 2, which means x is equal to 10 square, or x is equal to 10 power negative 2, which will give me two different answers. Wait, let me move this aside. Okay, then for this means that x is equal to 100, or x is equal to 1 over 100. And that's the end of question 7 part A. Okay. Next part, question 7 part B. Okay, I am given this log equation over here. What can I do? Okay, very simply, I just need to combine all the log terms together. Okay, so in this case here, what can I do is that I can, let me combine together. Okay, what I can simply do, okay, remember I cannot combine terms using product law if the coefficient is not 1. So I must bring in this 2 by the power law first. So 2 log 5 is the same as log 5 power 2 plus log x minus 1 can be written as log base log 10, okay, plus log 2x plus 3. Okay, then from here, this can combine. Now I can combine by product law. This will be log, then this will be 5 squared is 25 times x minus 1, okay, equals to log, this will be 10 times 2x plus 3. Okay, so I got one log term on both sides of the equation. I can then simplify this to become, by just comparing the terms inside the log function, 25 times x minus 1 equals to 10 times 2x plus 3. Okay, so this will give me 25x minus 25 equals to 20x plus 30. So very simply, this means that 5x is equal to 55, x equals to 11. And we are done for part B. Okay? Alright. Okay, let's now look at question number 8. Question number 8 here. Coefficient of x power 10 is 252 in this expansion here. Show that the value of k is equal to 2. So, very simply, if I'm given one term here, the x power 10 term, this means that I have to use a general term formula. So, recap again. By general term formula, we know that Tn is equal to n choose r, a power n minus r, b power r. Okay, so by looking at this expansion over here, we identify what is my a and b. Okay, I know that from this expansion here, a is equal to 1 over 2x, b is equal to k x power 3, and the n is equal to 10. Okay, so by substituting this into my general term formula, Tn is equal to 10 choose r, a is 1 over 2x, the whole thing power 10 minus r, times b is kx power 3 whole thing power r. Then we simplify from here. Simplify the general term formula. Okay, I'll get 10 choose r. To get rid of the fraction, I can multiply negative to this entire power here. To flip this will become 2x power r minus 10. Okay, this r can bring into each individual term. This will be times k power r times x power 3r. Then from here, this power can bring into each number by itself. This is 10 choose r times 2 power r minus 10 times x power r minus 10 times k power r times x power 3r. Okay, and my last step is to combine all the x terms together. This will give me 10 choose r times 2 power r minus 10 times k power r times x power 4r minus 10. Okay, so therefore from here, I want to find the term, the r position of the term with power x power 10. So I let 4r minus 10 equals to 10. This means that 4r is equal to 20, r is equal to 5. That means in the fifth r, when r is equal to 5, that is the position of the term with x power 10. So if r is equal to 5, since the term number is r plus 1, this means term number 6 will have the power of x to be equals to 10, and this will be 10 choose 5. I sub in r equals to 5. I'll get 1 over 2x times 10 minus 5 times kx power 3, the whole thing power 5. Okay, then from here I continue to simplify. Then choose 5. Okay, simplify everything over here. Actually, to make your life easier, you can just sub into this thing over here. Okay, so I should have done that instead. Let me erase this. Okay, I'll get times 2 power 5 minus 10 times k power 5 times x power 4 times 5 minus 10. Okay, so by simplification, you should get, you will get 63k power 5 over 8, the whole thing, times x power 10. Okay, so therefore, we know that, since the question say coefficient of x power 10 is 252, this means that, therefore, 63k power 5 over 8 is equal to 252. Okay, so this means that, therefore, k power 5 is equal to 252 times 8 over 63, I'll get 32. Okay, and therefore, k is equal to fifth root of 32, which is equal to 2. And that is your answer to part A, shown. Okay, this is for question 8, part A. Next part, question 8, part B. Hence, find the coefficient of the term independent of x in this expansion here. So I know that this expansion, since k is equal to 2, it is 1 over x squared plus 32x squared times 1 over 2x plus 2x cubed, the whole thing power 10. Okay, so over here, in order to find the term independent of x, okay, this means that in this expansion here, okay, 1 over x squared plus 32x squared in this expansion over here, I want to find the terms when multiplied to these two terms here, it will give me a term independent of x. In this case, x power is 0. So that means I want to find a term with x power 2. Because when I have a term with x power 2, multiply to 1 over x squared, I'll get x power 0. I want to also find a term with x power negative 2. Because this x power negative 2 term here, when multiplied to 32x squared, it will get x power 0 as well. Okay, amongst all the terms in this binomial expansion. Okay, so to find x squared and x power negative 2 terms in expansion, in the binomial expansion, okay, I will remember the general term formula of this, the x power 4r minus 10, I let this to be equal to 2 and 4r minus 10 to be equal to negative 2 to find the position of the terms. So over here, this means that 4r is equal to 12, r is equal to 3, 4r is equal to 8, r is equal to 2. Okay, so this means that term number 4 is when r is equal to 3, then choose 3 times, I look at the general term formula again, 2r minus 10, okay, 3 minus 10 times 2, I know k is 2, r is 3 times x squared. Okay, so term number 4, we can calculate, use our calculator to calculate this. Term number 4, the term is 15 over 2 x squared. Term number 3, okay, maybe I split over here. Term number 3, when r is equal to 2, then choose 2 times 2 power 2 minus 10 times 2 power 2 times x power negative 2. Okay, term number 3 will be 45 over 64 x power negative 2. So therefore, constant term in this expansion, 32x squared, then in this expansion over here, I found the two terms would be to be plus 15 over 2 x squared plus 45 over 64 x minus 2, okay, is equal to simply, I take this first term here, multiply to this first term over here, okay, 1 over x squared times 15 over 2 x squared plus, the next one is this term here, 32x squared multiplied to this term over here, which is 32x squared times 45 over 64 x power negative 2. Okay, further simplify everything, you should get 15 over 2 plus, over here you will get 45 over 2. Final answer should be equals to 30. And we are done for question 8 part B. Alright. Okay, so this is for the binomial theorem question.